Hello to everyone who is watching. This is a short video describing my project in the course Advanced Programming. Main programming language is Java. Lecturer is Dr. Eliahu Khalstzchi, who deserves many thank yous. Let's move to the project's milestones. The project was divided into 5 milestones. The first milestone was centered around solid principles and planning the search server design according to those principles. The second milestone is centered around streaming in Java, threading, and implementing the search server with a demo problem, a very simple problem. The third milestone is centered around implementing BFS algorithm into our server, thereby making it a real search problem-solving server. The fourth milestone is centered around creating an interface and implementation for controlling the flight gear simulator via semi-REST API, meaning from afar. The fifth milestone is centered around creating a GUI with JavaFX using MVVM architecture for controlling the flight gear simulator. Now, in this milestone, the fifth milestone, we actually connected all the other milestones into a final product, which I will now show. Let's start the server. This is our first server on port 5000. The client is our GUI. Let's get rid of the console windows. Here, I am starting a server on port 5400. The flight gear simulator, when it opens, knows to connect to this server as a client. Let's start. This is a pretty heavy program, so it will take a minute to load. In the meanwhile, I will show you the map and how it works in connection to the search server. The map gets a CSV file, which is actually value separated by commas, and translates it into this map. The higher the value, the greener the cell. Let's connect to the server. First, let's set a destination. Now let's connect to the search server. You can see it calculates the shortest path, and if I move the destination, it calculates the new path, shortest path of course, automatically. Now let's connect to the flight gear simulator as a client, and let's load the script. I will explain about the script in a second. Clients at once. So once we are connecting from the map as a client, and once we will connect from here, from the script as a client. Here in the map, the client 4 times a second asks the flight gear server which position the plane is in, and it can change the position of the airplane accordingly on the map. In here you can see a script which is kind of like a programming language. In my project, I implemented a parser which parses this script and interprets it into commands which the server can, of course, understand and change the behavior of the plane accordingly. So let's start the autopilot and see how the plane takes off. If you look at the map, you will see that as the plane progresses, the map will change the position of the plane accordingly. The plane doesn't fly according to the shortest path because it's not in the... I didn't implement this option. So it flies according to this script. You can see how the plane changes position. Let's move to manual. And you can see how the plane reacts to the joystick, rudder, and we can turn off the throttle. Now, before it crashes, let's close this, let's close the data server, let's close the GUI and move to the presentation. This is the design of the search server. I won't discuss it now because it will make this video very long, but it's very interesting and I recommend looking at it. I think it's very clear. In here you can see the best first search algorithm and the class diagram, which strived to make the searcher as general as possible. So in here you can see an interface, an abstract class which implements this interface, and we can implement as many actual algorithms, search algorithms, and using a searcher which is a general, an interface which is a general kind of object, we can solve the same map, which is kind of like dependency inversion. The server-side search algorithm implementation had a few problems. For example, the server's client handler is expecting an object which implemented the solver interface, this interface. But the BFS algorithm implemented the searcher interface. Common searcher, as I said, is an abstract class which implements the searcher interface. This is done for a reason, we don't want to change it. So the solution is an object adapter. In here you can see that the searcher to solver adapter implements the solver. It has a data member which is a searcher, and using its solve method, it actually uses the searcher search method. Now, the client side uses MVVM GUI architecture in JavaFX, meaning we have the view in here, the model, and the view model. Like the wheels here, the view and the model shouldn't know each other. All the commands are passing through the view model. So in here you can see the view knows the view model, so it uses the view model load script from file. The view model uses the model get script from file because the view model knows the model. It actually knows the abstract type, the interface. The model does the actual logic, scans the file and takes the content and saves it in a data member. This is a data member of the model. Now, after it sets it notifies the observer. The observer is actually the view model. The view model notifies the view, which is the view is the view model's observer, and the view changes the script area text accordingly. This is observer pattern. I think this example shows the behavior, the power, the strength of the observer pattern very well. Like this shows the power and, like I said, the strength of object adapter very well. Let's move on. MVVM using JavaFX also uses data binding, and it's very highly recommended, so I tried to use it as much as possible in my project. For example, this is the fXML, which actually defines how the GUI looks, and in here you can see color map and the ID. And in the main window controller, which interacts directly with the view model, I used data binding. And that's it. Thank you very much for watching.